So now I'm going to go through question 14 on June 18 paper 2, which you may struggle with this just because we haven't properly done rates of change yet. So that's probably why this question felt more difficult, and also it's just a bit of a tricky question as well. So let's look at it. So it says mice on an island. So the number of mice, n, in the population after t months is given by that equation there. And then we want to find A is quite straightforward. That's why it's only 1 mark. The number of mice at the start of the study. So that's basically we want to find n when t is 0. That was supposed to say when, but it just became a scribble. So n when t is 0. So let's have a go at that. So n is equal to 900 over 3 plus, and it'll just become 7 e to the 0, because obviously when you multiply through by 0 for the t, it's just going to make that whole bit 0. Anything by 0 is 1, so it's going to be 900 over 3 plus 7, and that'll just be 900 over 10, which will just, I don't know why it's missing parts of my numbers. So that will give us an answer of 90. So that's part A. That bit is the easy bit. I'm assuming that's not the bit we struggled with. So then let's look at part B. So part B is show that the rate of growth dn by dt is given by that thing there. So we want to find dn by dt. So let's start with n, and then we're going to differentiate with respect to t. I'm going to rewrite n, just make it a bit easier for me to differentiate personally. So I'm going to keep the 900 here, and I'm going to make it 3 plus 7e to the minus 0.25t to the power of negative 1. I'm going to make it that because that just, it makes my brain happier when I'm differentiating that. So we're going to use chain rule to differentiate that. So I'm just gonna, the 900 bit is just gonna stay as it is. That's gonna stay as 900. Then the bracket, we're gonna bring that power down, so that's gonna become a minus 900 and reduce it by 2. So that'll be 3 plus 7e to the minus 0.25t, power of minus 2. Sorry, I'm gonna shut the door because I'm worried there's background noise. So we end up with that, and then I have to then multiply that by the bit inside the bracket differentiated. So let's do that. So the 3 bit is just going to disappear completely, and then we're just going to bring that minus 0.25 down. So that'll just become, I'm just going to make it minus 7 over 4, and then the e to the minus 2.5 t bit will stay the same. So that'll just be e, yeah, I know, e to the minus 0.25t. So that is what it is. I'll zoom out just so you can see what that is, because it's quite a lot there. Still can't see it. Let's try again. There we go, you can see it now. So as we can see, that doesn't look like what we wanted. We wanted n's in it. We've got e to the power of 0 minus 0.25t's in it. So what I'm going to actually do here is I'm going to use my original equation, because I know that's got n and t in it. And I'm going to try and replace all the t bits with n. Now, I would say normally we'd rearrange to make t the subject. I think that you could, but you're going to be there for quite a while. So I think there's easier ways we can do it, because I can see that 3 plus 7e to the minus 0.25t, I can see that in both my expressions. So I'm going to utilise that fact and make my life a little bit easier to do that. So let me get that. So you can see that first bit there, and we'll do the second bit in a moment. So what I'm going to do here is I'm just going to do this. So I'm going to say that n, I should be writing, there we go. So I'm just going to divide through by that 900. That's a 900, not a 960. Let's just, you know what, we tried 0. There we go. So I'm just going to divide through by that, and that gets me 3 plus 7e to the minus 0.25t to the power of minus 1. So I can see in my equation that I've got there, I have that in my differential to the power of minus 2. And here, it's the same time minus 1. So let's just square both sides. And then that, I can just replace with that, can't I? Also, before I carry on, I'm also just because I can see I've got a minus 900 there times by that minus 7 over 4. So I'm just going to cancel that out just while I've noticed that. So we don't need to deal with those negatives because there's no point if we don't need to. So I've got that. And then I then have, so that's that first bit taken care of. Then I've got this 7 over 4 e to the minus 0.25t. So that's going to be a little bit more tricky. But I'm going to go back to this thing here and I'm going to try and get that 7e to the minus 0.25t. I think that would be the easiest substitution to make there. So before I squared everything, it was n over 900 is 3 plus 7e to the minus 0.25t to the minus 1. So what I'm actually going to do is I'm just going to flip everything. So I've got the reciprocal. Because when I do that, that'll give me 3 plus 7e to the minus 0.25t. Because remember that it was the power of minus 1 before. So then I can rearrange that now. So I can do n over 900 minus 3. 900 over n minus 3 is equal to that 7e to the minus 0.25t. So I've now got this thing here, and if I go a little bit further up, I have that thing there. So I'm now going to use both of these and substitute them into dn by dt. So, apologies, I'm having to sort of move around the board a lot here. So, dn by dt is going to be equal to, so that 3 plus 7e to the minus 0.25t to the minus 2, I'm just going to make that n over 900 squared, because that was what I determined it to be before. So that'll be 900 times by n over 900 squared. So that already looks a bit nicer than what I had before. And then the next bit was that 7 over 4 e to the minus 0.25t. I've now rewritten that as n over 900 minus 3 is equal to 7 e to the minus 0.5t. So I just need to divide everything through by 4 when I substitute that in. So that will be multiplied by, so we'll make it 900 over 4n and then minus 3/4, like so. So now that's looking a bit more like what I want. I'm not quite there, but I'm closer. So now let's try and tidy this up and make it look like what I want it to. First thing I'm going to do is I'm going to deal with that front bit there. So I can see the 900s, one of them's going to cancel out. So that 900 there is going to cancel out and we can get rid of that squaredy bit. Obviously that would be an n squared there, like that. So we could do that. So let's do that. So I'm going to end up with n squared over 900 here is equal to 900 over 4. And what I'm actually going to do here, I think I might multiply that the second fraction, I might multiply that by n on the top and bottom there just to make it one complete fraction, because that feels, I want it as one complete fraction at the end anyway, so that feels like a logical step to make. So that will be 900 minus 3n all over 4n, like so. And then we can multiply that together. So that will become now, so we have n squared 900 minus 3n over 900 times by 4n. And I could multiply through by that, but I can say I want a 300 on top and I want a single n. And I've got 903n. So what I think is, I want to get that, I could just divide everything through by 3. So I could divide the top and bottom there by 3, and I'm hoping that will give me numbers that is closer to what I want. So this whole thing here then is then n squared, and then that will be 300 now. 300 minus n over 300 times by 4n. And then I should have done this before. Let's cancel out those n's there. So then that will give me n 300 minus n. And then the 300 times by 4 is my 1200. So we got there eventually. We got there eventually. And that is what we wanted. So just, if I zoom out and just go through that again, because it's quite a process that we took to get there. So we started by differentiating, and we got something with the 3 plus 7e to the minus 0.25t. I then used my original equation involving n to then rearrange those and tried to spot where I could make those easy substitutions. I then replaced my 3 plus 7e to the minus 0.25t and 7e to the minus 0.25t with my rearrangements, and then it was just a case of algebraic manipulation to get to here. And I will say, they normally do this when it's a, show that this is this. It's normally because they want you to use that thing in the next thing, and they don't want you to look. They don't want to lock you out the rest of the question, so just take note of that. So then that's part B. That was 4 marks. It felt like quite a lot of work for 4 marks, I think, but it's the last question, I guess. Is it last question? It's one of the higher questions anyway. So then it says, the rate of growth is a maximum after t months. Find, according to the model, the value of t. This is where you need to be really careful with the language they're using here, because this could trip you up. We want the rate of growth. We want the maximum rate of growth. That means we want the maximum of dn by dt. We want the max value of dn by dt. We don't want to find the maximum point of n, we want the maximum of dn by dt. So what that actually means is we need to differentiate dn by dt and find the maximum by making that equal to 0. Okay? We don't want max n, we want max dn by dt. So we have to differentiate dn by dt and make that equal to 0. I think it's the obvious mistake there is that you just find the maximum of n, not dn by dt there. So that definitely could trip you up. So this thing is going to be a lot easier to differentiate. So I'm just going to rewrite dn by dt in a way that would make my brain happier to differentiate it. So dn by dt, I realise I should probably zoom in again so it's not as thin, the writing. So dn by dt, I'm just going to expand the top bit. So it is 300n minus n squared all over 1200. So then we're going to find d2n by dt squared. So then let's do that. Let's do d2n by dt squared. So that will be, I think I'm just going to separate the terms out here. So the n would obviously just become nothing, and then 300 over 1200, that's just going to become a quarter, isn't it? So that'll just be a quarter when I do that. And then n squared, that's going to become minus 2n over 1200, which would just become n over 600, wouldn't it? So minus 2n over 1200. So that thing there will, therefore become a quarter minus n over 600. So I'm then going to set that equal to 0 because, again, I want to find the maximum. So I want to find the stationary point. So then n over 600, come on, is equal to a quarter. And then just multiply everything through by that 600. So that's going to get me that n is 600 over 4, which would be 150. So that would be, so that is the value of n. We don't want the value of n though, we want the value of t, don't we? We want the value of t, we have the value of n. So let's go back to our original equation. involving n and t. So we're going all the way back to the start now. So I think common mistake would be to stop there because you feel like you've done all the work. You haven't done all the work yet. Hang on. So n is equal to, which is just, let's just say that's 150 because it is at this, whatever we're trying to do. So that's 150, apparently. That is equal to 900 over 3 plus 7e to the minus 0.25t. That's what we get there. So then we've just got to do some lovely rearrangement of that thing there, haven't we? So let's think about what we can do here. So obviously we can, I might just multiply through by the 3 plus 7e, blah, 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 and divide by the 150. Let's just do that in one step. So that will be 3 plus 7e to the minus 0.25t. I'm getting a bit sick of writing that. And then 900 over 150. That is going to be, it'll be 6, won't it? I'm hoping. I'm thinking it's 6. So we end up with that. And then we can subtract the 3. So let's subtract the 3. So that then gives me 7e to the minus 0.25t is equal to 3. And then it's just a case of now just getting to t, isn't it? So e to the minus 0.25t is equal to 3/7. And then we're going to log that and then end up with minus 0.25t is equal to the log of 3/7. Log of 3/7, and then we're going to divide through by the minus 0.25, which is the same thing as multiplying by 4, or minus 4 I should say. So t is equal to minus 4, there we go, minus 4 log 3/7. And then if you bung that in on your calculator, that will be about 3.4 months to 1 decimal place. So I think the trickiest part of that is honestly just figuring out it wants you to find the maximum of the rate of change here. And you're trying to find the maximum of dn by dt, not the maximum of n. And that'll send you on the wrong path. And then just realising that you need to find t, not n, so subbing that in. Okay, final bit. We're almost there. We're almost there. So, part D. This question feels like it's very long. So, part D now is, according to the model, the maximum number on the mice is the maximum number of The maximum number of mice on the island is p. State the value p. So this is where we are trying to find the maximum value of n. So this time we definitely are trying to find the max value of n. And I feel like this question is meant to make you question if you did find the maximum of n in the previous question, it's meant to make you go, hang on, why are you asking me to do the same thing twice but giving me far less marks for it this time? So we want dn by dt to equal 0. So we already know what dn by dt is, we don't need to do all that. So we know n 300 minus n over 1200 is equal to 0. So that means either n is 0 because this 1200 bit doesn't count. It's this bit here that I'm interested in. So either n is 0, and considering what a maximum, I don't think it's that, or 300 minus n is 0. So therefore n is 300. So therefore the maximum value of n, I'm just going to write here, n max is 300. Or I should say p, because that's p. P is maximum number, n max, which is p, is 300. And that is that question answered. So yeah, definitely a bit tricky, especially if we haven't done rate of change as well.